Hello everyone. Let's attempt the multiple choice questions from this paper. So, question 1.1, I've just drawn the diagram for everyone. The question says, what is the correct expression for the weight? So you have A equals, so option A is n plus f cos theta, B is n minus f cos theta, C is n plus f sine theta, and D is n minus f sine theta. So the first thing I would do is I would focus on this force that's acting at an angle. So this one right here. So that force is acting at an angle, and the components for these forces, or for this force, one will point to the right like this, and one will point down. Now, the angle that's given is an angle to the vertical, which means that if I had to complete this angle here will be theta, since it's an angle to the vertical, which means that that's 90 degrees. Now, if I wanted to work out what this horizontal force is going to be, Fx is going to be F times, in this case, sine theta, because the side is directly opposite the angle. Now, if I had to focus on the vertical, I know that this will be theta as well because of alternate angles. That means the vertical Fy is going to equal to F cos theta. So this is opposite to what we generally know. So let's look at the free body diagram. So the free body diagram will look like this, where you have Fx, you will have the normal, you'll have friction since it's a rough surface, we'll have Fy, and we'll have Fg. Now, since the object is not moving up or down, it means that the forces in the vertical direction are equal. So it means that the normal is equal to Fy plus Fg. Now, if we want the weight, that means we take Fy across, n minus Fy equals Fg, and we know Fy is F cos theta, so n minus F cos theta equals Fg, which is option B. Let's look at this question. 1.2. The relationship between the velocity and momentum of an object is represented through the sketch graph below. Which physical quantity is represented by the gradient of the above graph? So remember, gradient is the change in y over the change in x. On my y-axis, I have momentum, so p. On my x-axis, I have velocity. So if I look at the formula for momentum, p equals m times v. If I want to get p divided by v, I can take this across. So p divided by v equals m, which is the mass. So the answer there is A. Question 1.3. The rate of change in momentum is equal to. So important here that we remember, the question is asking for the rate in change in momentum. So we know that F net times delta t equals delta p, which is the change in momentum. Now, the rate in change means we need to take the delta t over. So F net equals delta p divided by delta t. So this tells us the rate, and the rate is F net. So the answer is B. Question 1.4. Which one of the following combinations in the table best describes the effect of the arrestor beds on the force and velocity of the truck during an emergency stop? Now, an arrestor bed, if I had to sketch a truck, an arrestor bed is a surface that the truck drives on if the brakes fail. So the arrestor bed serves a purpose, and the purpose is to slow down the truck. Okay? So obviously we need to choose an option that says the velocity will decrease. So it's either going to be D or it's going to be B. Now we need to think about the force. Since the arrestor bed is slowing down the truck and slowing it down gently, the force will decrease. So the answer is D. Question 1.5. Stone X is thrown vertically upward with speed V from the top of a building. At the same time, a second stone Y is thrown vertically downward with the same speed V from the top of the same building. Air resistance is negligible. Which one of the following statements is true about the speeds at which the stones hit the ground? So let's draw a sketch. You have stone X thrown up and hits the ground. Then you have stone Y, which is thrown straight down. Now, what we know about the motion of X is that at some point here at the top, its velocity is going to be 0. And then as it comes back down, and once it reaches the point at which it was thrown from, its velocity is going to be the same as its initial velocity, just in the opposite direction. For example, if X was thrown upward at a velocity of 10 meters per second, then when it reaches this point, across from it, this point here, its velocity will be negative 10 meters per second. So it is as though Y and X are thrown at the same velocity. So they both will travel down, and when they hit the ground, they will hit the ground with the same speed. So the answer is A. And it's because once X reaches the same point, or the starting point, its velocity will be the same, but just in the opposite direction. Question 1.6. When the projectile approaches its maximum height. So important here, approaches its maximum height. The velocity will be 0, increase, decrease, remain constant. So this is trying to trick you, this question is trying to trick you, because we know at the maximum height, the velocity is going to be 0. But as it approaches the maximum height, as it approaches, the velocity decreases. So the answer is C. You can think of it like this. I mean, if it's thrown upward, let's go again with 10 meters per second, and it goes up to maximum height where the velocity is 0. What has happened to the velocity? It went from 10 to 0, meaning it decreased. Question 1.7. The motion of a projectile which bounces off the floor several times is represented through a velocity time graph below. So we can see this graph. Which of the following statements below are incorrect? about the motion of the projectile. Okay? So in the first one, initially the projectile goes upward. The projectile bounces twice off the floor. The initial velocity of the projectile is 0. Upward motion was taken as positive. So when I see a question like this, what comes to my mind is the shape of the graph. So I know that the gradient of a VT graph gives me the acceleration. Okay? And we know that if the graph is shaped like this, then this is a positive slope. And if it's sloped like this, that is a negative slope. Now, since the slope is positive, we can see from the shape of these slopes, that way, that way, that way. Since it's positive, it means that the acceleration was positive, since the slope represents the acceleration. And if the acceleration is positive, it means that down was taken as positive. Since for vertical projectile motion, acceleration is 9.8 down. So downward is taken as positive for this whole question. So we can eliminate 0.4, that's out. So if we had to draw a sketch of what's happening here, say we have a cliff. Since down is positive, and you can see that the velocity is increasing in a downward direction, it means that the object was thrown down. So if it's thrown down, it's going to hit the ground there. And that's this point. This point here on the graph. That way hit the ground. Then it returns upward. Up to a point. And then it comes back down. And then it goes back up to a point. Now we can color code these, so it's easy to understand. Let's use yellow. So yellow is representing this motion going down, and there's it there. You can see that the velocity is increasing. Then it's returning up. So this is negative velocity, since down is positive. So that's going to represent that part. Then you have the object going back down, increasing velocity, so this region here. And then going back up again, negative direction there. So we can see quite clearly that it's bouncing twice. So it hits the ground here, and it hits the ground there. So that's the first bounce, that's the second bounce. So we know 2 is true. Initially the object goes upward, that's false. And the initial velocity of the projectile is 0, that's also false, because you can see here that it has some velocity. So 1, 3, and 4 are false, so that's going to be option C. 1.8. Which one of the following is the correct condensed structural formula for 2,3-dichloro-2-methyl pentane? So this question, it's easiest if you just draw it out. So pentane, so there's 5 carbons, 1, 2, 3, 4, 5, all single bonds. You have a 2,3-dichloro, so if that's the first carbon, that's the second carbon. 2,3-dichloro, so that means you have a chlorine there, and you'll have a chlorine on carbon 3. Then you also have a 2-methyl, meaning you're going to have a CH3 here. And pentane, so there's hydrogens everywhere else. Like this. So if you wanted to do the condensed structural formula, you could do it like this. You could say, okay, that's CH3, then C, then Cl, and then since this is a branch, we show it in a bracket, so CH3. Then you have C, H, Cl. Then you have CH2, which is this, and then you have CH3. Let's see which one matches up. That's option B. 1.9. Which one of the following molecular formulae represents an alkyne? So an alkyne follows the formula CnH2n-2. So it's just a matter of picking the one that follows that. So if I look at A follows C6H10. So C6H2 times 6 minus 2, that's C6H10. So this one is an alkyne. The option is A. And last one, 1.10. Which of the following organic compounds has the highest boiling point? I've mentioned it in previous videos. Butane is an alkane. They have London forces, which are quite weak. Butanone, which is a ketone, that's dipole. You have butane 1-ol, which is an alcohol, and alcohols have hydrogen bonds. And then you have butanoic acid, which is a carboxylic acid, that's also hydrogen bonds. So the option is between the alcohol and the carboxylic acid. And I mentioned in the previous video that carboxylic acids have 2 hydrogen bonds, whereas alcohols only have 1. So butanoic acid will have a higher boiling point.